So, we are going to start chapter 2. Yeah. We'll finish chapter 2. Yeah, some other time. We won't finish it today. Promise that. That's the promise that I can make to you, is that we won't finish it today. We will be having a formative assessment this week, though. Okay? So Friday will be a formative assessment, and it'll be one where you just turn it right in. So you take it and turn it in, and I'll correct it. Okay? It's just the last one I had you guys correct because it was so close to the test. So, okay? Chapter 2 deals with linear functions and linear equations. Okay? So my question to you is, what is a linear function? You've seen them before. What is a linear function? Linear function. No, what is it? It's what? Do you know that you're in the Department of Redundancy department? All lines are straight. So when you say straight line, you're being redundant. What? It's a line. That's it. That's the whole thing. Oh. A linear function is just that. It's a function that graphs into a line. You don't have to call me Jesus. You can just call me Liz. I can only walk on water when I know where the big stones are. Borderline hilarious today. Key there is borderline. Yeah. Okay. So what does a function look like? A linear function, I should say. Again, the Department of Redundancy department. So what does it look like in terms of its equation, I should say? Okay, y equals mx plus b would be the linear form of it, okay? But it may also be written in function form, okay, or function notation. And then the difference between linear form and function notation is f of x. Y becomes f of x. But when you're doing it, in your brain you're saying, well, f of x is y. Okay? So in xy notation, it's y equals 3x plus 5. In function notation, that exact same line, if you will, I don't want to say straight line, is f of x equals 3x plus 5. Oh, man. Well, the air pressure did change a little bit, yes. Did you know that that's what, when you suck through a straw, you change the air pressure, and so that's how the liquid comes up, because it fills in the low pressure. No problem. I'm here for you. I'm not all about math. Numbers are my gig, but I'm about life. Straws are life. Do you know, you might not have known this, but there was a time in my life where I was fat. Like, really fat. At one point in time, I weighed 400 pounds. Okay? And then I had surgery. and they told me, they like put the fear of death in me that I couldn't use a straw because of my new stomach and all that stuff like that. They just tried not to make me drink through a straw. Why, I don't know.
So stressed with her.
Yeah.
Just in time.
Okay. So, functions can be evaluated for any value of x. Okay. What I mean by that is if f of x is equal to 3x minus 4, then I want to find what f of negative 2 is. So I'm going to take this number and I'm going to plug it into whatever my function is. Okay? So I'm going to take that value and plug it into my function. So this then becomes, I want to find f of negative 2. So I would take negative 2 and I would replace x with it. Then I do the math. 3 times negative 2 is negative 6. Negative 6 minus 4 is negative 10. So f of negative 2 is negative 10. Okay. Last time too, where there it goes. Yeah. What I would like you to do now is I would like you to evaluate h of x and g of x, or j of x, excuse me. Find me h of 4 and j of 2. So h of 4 is going to be 2 times 4 and then plus 6. So that's going to be 8 plus 6. So I would say here that h of 4 is equal to 14. Yes? Okay. Then down here, I would say that j of 2 is going to be equal to 3 times 2 squared plus 6 times 2 minus 5. 2 squared is 4. 4 times 3 is 12. 6 times 2 is 12. 12 plus 12 is 24. Minus 5 is 19. So I would say then that j of 2 is 19. Agree? We are going to take our linear functions and we are going to graph them. Okay? We are going to utilize them and graph them. This is where the pink paper is going to come into play. Okay? So if I have 4 ways, I can think of 4 ways to graph a linear function. You may be able to think of another way. Okay? Remember that a linear function is going to be f of x equals mx plus b, or really we're talking y equals mx plus b. way to graph a linear function? What's one way? By plotting points? Okay. So, which points would you be plotting? You remember a way that we can find points on a line? Okay. It's called the T-chart. Freddie, is that what you were going to say? Okay. What do we do in a T-chart? However many you want. So you pick X's, and then get the Y's. What if I wanted to pick Y's? So I could pick Y's. I got to pick one of them and plug those in and get out the other one. Okay? And that gets us points. And then those points, then we connect them, and we're good to go, right? Okay? Fantastic. What's another way? A calculator. Or your Chromebook, or your phone, or some kind of a technological type thing, right? I think I spelled that right. Close enough. Okay? So, graphing calcs, Chromebooks, phones, etc. Okay? The downfall with using technology is that you got to reproduce it on your sheet of paper then. Okay? So you're kind of doing double the work because you got to do work to put it onto your technological device, and then you got to do more work to put it on your paper so that you can prove that you did it. You know what I mean? Okay? So it works, but it's not my favoriteest way. Okay? The next two are probably your go-to. Okay? They're going to be your jam when it comes to graphing stuff. Okay? The first one is the way that you've probably been doing it forever. Okay? So you're going to graph the y-intercept, which is the point 0, comma b, and then use the fact that your slope is rise over run to get some more points. My guess is that's how you all graph lines. Plot your y-intercept, use rise over run, get 3 or more points. Go. The last way is intercept way. How many points does it really take to make a line? How many points do you absolutely need to make a line? 2. You only need 2 points. Okay? So one of your points could be the y-intercept. Well, the y-intercept is where x is equal to 0. It comes in the form 0, comma, some number. In this case, we'll call it y. Really, it's 0, comma, b. Okay? But your other point that you can graph, relatively easy, is called the x-intercept. It is where y is equal to 0, and it comes in the form some number, comma, 0. So you can plot those 2 points, or find those 2 points, plot it, and there's your line. Okay? Now, the only thing that I ask, okay, I don't ask for much. Okay? My OCD is at a level that most people, all of you in this room combined probably still wouldn't reach my level of OCD. Okay? So I don't ask for much. But what I ask for is this. That when you are drawing a line, you use something that is straight to draw that line. Okay? And there are many, many things that I can see on your desks right now that would allow you to draw straight. Okay? Right? You can use the edge of your folder or your binder. You can use the edge of your phone. You can use the edge of your textbook. You can use your ID. You could use your driver's license. You could use a ruler. You could use a protractor. You could use an extra pencil. You could use your planners are ginormously straight. Okay? Because they got that nice, hard, like plastic type cover. That's a phenomenal straight edge to use. Okay? Tons of stuff. Okay? What's her water bottle back there? Is that sparkling ice? Yeah. Sparkling ice bottles. Okay? Make sure the cover's on tight though when you tip it on your side. When you tip it on its side. Otherwise your paper's gonna get all wet. Right? Right?
There's other colors too.
What?
There's other colors too.
I know there's other colors. Okay? But there are many things that you can have to make sure that your lines are lines, because lines are straight. Okay? Okay? That's all I ask. I'm asking for much. Okay. So, let's graph a couple lines. Okay. So, either form, we're going to do the exact same thing. If it's y equals negative 3x plus 2, or if it's written as f of x equals negative 3x plus 2, we're going to do the exact same thing. I'm going to take graphing calculators out of the mix here, or Chromebooks out of the mix, or your phones out of the mix for this one, because that's double the work. So I'm going to take those out of there. So you can either make yourself a T-chart, graph it like you normally graph it, or graph it the intercept way. Okay? How you want to do it? Do a T-chart? Okay. So pick me some X's or pick me some Y's.
Alright, well, let's do, what do you mean like wisely?
You can either pick X's or you can pick Y's. I don't care.
Oh, okay, let's do for X's like 1, 3, and 5.
1, 3, and 5.
Wait, don't you have to have 0?
No,
Oh, you don't.
you don't have to. So if I put 1 in for X, that gives me negative 3 plus 2 is negative 1. So I go through the point 1, comma, negative 1. If I put in 3, that gives me negative 9. Negative 9 plus 2 is negative 7. 2, 4, 6, and 7. And 5 would be negative 13. Which is off my chart, which is fine. Totally. Okay. Enough to make yourself a line? because I got at least 2. Okay, you only really need 2. Okay? What's another way of doing it? So let's do it this one a different way. What's my y-intercept? So I go up 2 from the origin, right? And I put a dot. Okay? Then from that dot, my slope is -3. So then that means I go down 3, 1, 2, 3, and to the right 1. So I'm at Lexi's first point. Down 3, 1, 2, 3, and right 1. Down 3, 1, 2, 3, and now I'm at Lexi's second point. Okay? So we're going through the exact same points. Okay? What if I don't like going down and to the right with the slope way? And up and to the left. 1, 2, 3 up and left 1. 1, 2, 3 up and left 1. Okay? Now I can draw in my line. And lines are what, Freddie?
Straight.
They are straight. I also ask, I know I'm so demanding, I'm asking 2 things of you with these lines. Make them go all the way across your graph. Okay? There's nothing that I despise more in my OCD-ness than this. Exactly. Exactly. It makes me cringe too. Okay? Slide that sucker all the way across. Okay? Be proud of your graphs. YB? That's the equity. Graph that one. I don't care which method you choose. Y-intercept of -3. So I go down 3 from the origin. A slope of +2. Up 2, right 1. All the way through. Or down 2 and left 1. So I could go through the point 1, -1, 2, 1, 3, 3, 4, 5, 6. Or excuse me, 5, 7, 6, 9. -1, -5, -2, we have to break that one off by a little bit. Missed that one down here. There. -2, -7, -3, Okay. Functions are relations. Okay. A relation is a mapping or pairing of input values with output values. Meaning you put something into an equation or a function or a relation and you get out a value. Okay. Before, we put 4 into our h function and we got out a value. Okay. We put, was it 2 or -2 into f and got out a value. We put 2 into j and got out a value. Okay? With relations come 2 wonderful components. Okay? The first one is the domain. Okay? We can find the domain of a relation by listing all the input values. Okay? That's your x's. What's going into the function? We can find the range then by getting all the output values. Okay? So domains are x's, range are y's. That, ladies and gentlemen, is something that is note card worthy. Because that will mess you up. We give the domain and the range in set notation. Set notation is those funky parenthesis bracket type things. Okay? Now, truth be told, my brain knows what those things are. Okay? But when it sends the signal down my spine, into my right arm, and to my right hand to draw them, it gets lost in translation. Okay? I can't draw them things. Yeah? I can't. Flat out. I can't do it. Okay? So, if you are like me and can't draw them, I give you my version of those. Okay? Alright? I can draw one of them. I can't draw the other side. I can't do it.
Can you try? Let me see.
You'll see it a bunch of times. Okay? Yeah, we'll be doing it. Okay? So, if you want to just put squiggles, that's fine. Okay? I'm okay with the squigs. Okay? So, there are 4 ways to represent a relation. Okay? So, I will use the exact same relation in the 4 methods, or the 4 ways. Okay? The first way is you could write your relation as a set of ordered pairs, or a list of ordered pairs. Okay? Simple, straightforward. Okay? Or, if you don't write it as an ordered pair, you could also write it as a function. Okay? So you can, relations are functions. So you can write it out as a list. Okay? List or a function. Simple, straightforward. You could make a table out of that. Okay, because here's the point 4, 2. Here's the point 3, -1. 1, negative, or 1, 5, and 4, -1. You could graphically represent that function. In all of them so far, the domain has been my x values. The domain is, oops, I see I put a parenthesis there. That should have been a parenthesis. That should have been a squiggle. -1, 3, and 4. Because I don't repeat numbers in my domain or in my range. Okay? So that's been the domain throughout all 3 of those representations. My range has been -1, 2, and 5. Again, I don't repeat the -1. Okay. The new concept today is a mapping. A mapping takes the elements from your domain and it puts them on one side, and it takes the elements from your range, puts them on the other side, and then you just draw arrows. So this arrow right here, the first point was 4, 2. So that is represented right there. That is the point 4, 2. 3, -1. -1, 5, and 4, -1. Okay? It's just a lot of funky arrows. That's all. Okay? So let's put this to work now. Okay? So find the domain and the range of the relation and draw a mapping of the relation. Okay? So the domain is the what again? The x's. Okay? So here's an x, here's an x, here's an x, there's an x. Okay? So I would probably write this out as -3, 2, 5, and 8. I like to write them out in order. My range, bless you, oops, there, 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 and there. So my range here would be -1, 4, and 7. Now, to draw the mapping from that, so I take my domain and I go -3, 2, 5, and 8. And if you want to put it in a box or put it in a big circle or a big oval, that's cool. That's you. Okay? If you don't, that's fine. And then I take my range and I go -1, 4, and 7. Okay? Now I draw arrows to each one. So the point 2, -1 is there. 5, 7 is there. -3, 4 is there. 8, 7 is there. And there's my map. Yes, ma'am. Domain on the left, range on the right, arrows to which point to how they're linked. Okay. One last concept. A true function. Okay. We've been bantering out the word function here for a while. A true function is a special relation for which each input has exactly one output. Each element of the domain is assigned exactly one element from the range. Now that's fancy book speak for saying this. A function has no repeated x values. There's no repeats in the x's. Okay? So if I go back and I look at this one, are any of the x's repeated? No. So this relation is a function. Here, are any of the x values repeated? Yeah, we got 2 4s in the domain. So this is not a function. Okay? Here, on these two, are those functions or are they not functions? Those are both functions. No repeated on the x's. Okay? Every x is only going to give out one y. Okay? One more. There it goes. Okay. So, decide whether or not a and b are functions. Well, what do you look at? X values. Are there any repeats in a? Then it's a, yeah, that's a function. In b, is it a function? Why not? There's two negative ones, so it's not a function. Okay? Now I'm going to go kind of quickly because I'm running out of time here. Okay? Well, come on now. Sure. Function, not a function. Yeah, that's a function. Function, not a function. No, got a repeat of ones, right? Okay, hold on, don't be packing up yet. Okay? Graphically, how can I tell if a function is a function? Okay, let me throw up three different kinds of functions. This is a cubic function. This is a square root function. This is a parametric trig function. Left one, function, not a function. Yes, it is a function. Middle one, function, not a function. Yes. Right one, function, not a function. Why not? What do I do? On graphically, how do I tell if it's a function or not? What kind of line test? Vertical line test. Okay? Tap the brakes. Do not be packing up when I'm still talking. That is rude. Okay? Vertical line test. Okay? If you take a vertical line, and again, you've got a ton of vertical lines with you. Pencils, pens, phones, IDs, planners, edges of your paper that you can roll across there. Okay? Water bottles, tons of vertical lines that you have at your disposal to slide across the graph to determine if it's a function or not. Okay? If that function or that suspected graph touches your vertical line in two spots, it's not a function. If it only ever touches in one, it is a function. Okay? All right? You will need a white sheet of graph paper tonight for your homework. Remember, pink ones are for class notes, white ones are for homework, so I will go hand them out right now.